1, 2, 3, 4. Welcome to the At Scale podcast. This is actually our second episode. And today we're having Mohamed Fawzy from NVIDIA. We'll be talking about GPUs, about system, about self-driving, and even cover some RV story. We are coming right off from the System and Reliability at Scale event, and then we're transitioning to this talk. So please join us. Nice to see you. Nice to catch up.
It's really nice to see you too.
Yeah, thank you for pitching in the conference. Totally appreciate it.
I thank you for organizing such an amazing conference. It's really great to come together and see the community and familiar faces. It's really refreshing.
Yeah, it's great. It's like, I always get a rush after. So the before, it's super stressful, but
Exactly.
after I'm super happy about the results and everything. For people listening, we've worked together in the past,
We did. Yes.
back at Meta.
you still
Back
at
when
Meta.
when it was Facebook. Sorry
Right.
about that. And then since then you had quite a journey. Can you recap a little bit, where you were
Absolutely. So I had amazing time at Meta. I joined in 2012, I think, late 2012, and spent 8.5 years. It was just incredible time, and so Meta grow, and it was back then Facebook. So
Yes.
I left before Meta transition. But then I went to the self-driving domain, and it was really a big change. It was really interesting change as well. Because with Meta, we dealt a lot about the scale. Scale
Yep.
is second nature,
Yep.
right? And we focused a lot on ads and feed and Instagram, like really large customers and large footprint. And with self-driving, it was very different. There wasn't that many models or many variety of models. They were very focused and dedicated. And the problem was really different. The problem was actually about data, particularly about long tail, which is a really interesting problem. When
So
you think
in
about
the long
self-driving.
tail, in this case, I would say, for people familiar with the Bay Area,
Right.
El Camino, you have a lot of data. and then small streets and stuff like this, it's...
Well, long tail as in, events that doesn't happen frequently.
Okay.
So, fun story and true story. I was driving in San Francisco once, and I actually saw a toilet on the side of the road. How many times do you see that? Right? It's just incredible. You don't see this every day. It's a very rare event. So how do you deal with it? We human can process and reason about it. But for the AI to reason and understand how to deal with such a thing, you need these examples. You need this long
You
tail.
need it multiple times.
Exactly. So that the models can learn and the model can tweak, and the behavior of driving is natural as well. So it mimics user behavior. It mimics a driver, right? So the problem with self-driving was really a lot about data and how to find these examples and find the long tail example. And this is when I realized the scale here was in a different nature. Scale wasn't the scale of infrastructure or scale of how large are the models necessarily, but how efficient are your data systems in order to find a mine for these problems. It's like a needle in a haystack.
Yeah.
How do you find a needle in a haystack when you have such a lot of data while you're driving all day, but you really are interested about these unique examples, right? So this was an eye-opening for me. And then this also showed how important it is to invest in data tools for debugging as well, right? And this is when I actually realized a lot about developer productivity is tied to how efficient are your data systems in terms of debugging your examples and understanding how your examples are actually impacting your models. And there's some incredible stories about how we improved model developer velocity by just focusing on, providing the right tools to understand, did this example actually help my model to improve? Is this helping me drive better? And just trying to answer this loop, what we call it data loop, resulted actually in an efficient training system. Because otherwise, it becomes a problem like shooting in the dark. You walk in a dark room, you don't know where is the light switch, so you start to touch all the walls trying to find it, right?
Yeah.
And it really, without the data, that becomes how model
So
training looks like.
these tools are about like data kind of like lineage type of thing. That data was processed from this subset of data type of thing so that you can backtrack.
More about data mining. It's
Mining. Okay, all right.
So first step is mining, as in like finding the relevant example. And how do I actually describe the relevant example? And how do I search for it? This becomes like a data search problem, sort of. And we used actually AI to...
interesting.
Yeah,
Okay.
like, you know, foundational models so that you can describe a scene and say like, hey, find me examples where a stroller, like somebody like pushing a stroller crossing the road and such like stuff like that, right? So you can describe examples, and this is way before the LLMs, and then now LLMs, and this is even like opens a new opportunities, right? And then tools like, hey, now I trained my model with such data. Which one actually of these examples improved my model performance? Which actually is a very common problem.
Yes.
That goes beyond self-driving. It's just accepting self-driving. This problem is very important because there is safety constraints around it, right?
Driving is like, you know, very black or white at the end of the day.
Exactly. And like, you know, these problems we also had in Meta actually as well. Like we called model understanding.
Yes.
Sort of problems, but it wasn't the impact of serving an ads, a wrong ad to the user. You know, it's not a big
It is
deal.
okay. Yeah.
You probably will end up like buying this thing anyway. So it's still good, right? But the impact of self-driving is definitely like severe.
I think one of the problems that I'm seeing a lot right now is tracing back to which piece of data. Like we run a lot of models for everything, from integrity problems, from ranking, from suggestion, from all stuff. And then we suddenly realize that, hey, that metrics is trending down.
Yeah.
So since we run so many models at a given point in time, it's kind of difficult to first pinpoint which one.
Yeah.
Then when we can pinpoint it, like production models, they end up with a pipeline where data gets processed, signal gets processed, gets aggregated, and then there's multiple phases.
Yeah.
And figuring out which phase is actually causing the problem is really difficult.
Exactly. It's like debugging at scale. Like you have a bug somewhere in a very complex system, and how do you find it, right? And it's same with models, right? Except the maturity of our tooling around that is way behind when you compare it to the typical software development, right?
Okay. If I go back in time a little bit in the history when you were at Facebook and you were like in AI infra at that time, if you look at where we are today, do you remember like, you know, something where, hey, we made the wrong hypothesis there. We went totally sideways. And you look at it today, we were in a cornfield type of thing.
Yeah, if I have a time machine, I go back, what should I do? There are a few of these actually. And I look at them as like, you know, these are great learnings. And what did we learn from the past, right? So early in the days, I would say circa 2017, right? Distributed training was coming hot. I was like, okay, how do we harness the power of distributed machine learning into upscaling our models and processing more data and driving more model complexity? And back then, I think a lot of our machine learning systems in Facebook was running on CPU.
Yes.
Except like maybe computer vision models were running on a little bit of GPU, right? So when we started to approach the problem, we started to do more of the same. Like, hey, let's scale using what we know, right? So let's throw more CPUs at the problem. How do we scale horizontally using like CPU machines, which actually brought a lot of complexities around infrastructure. It stresses the network to like an incredible limit that we haven't seen before. It also had an algorithmic component because we were training with asynchronous models, asynchronous algorithms that had a challenge in conversions, like accuracy of the model, right? So, and then like looking back in time, like you say like, hey, if I were to change and make a bet, I would have made a bet, double down more on GPUs back then and double down on more full sync training, which becomes more like a standard right now. But it's only becoming like, you know, available because of the infrastructure investment that we put over the years, whether it's networking or upgrading our data center, like the way that we designed our data centers in terms of like, you know, networking and how do we co-locate data and compute and like advanced a lot of system along the way. So I think that was a very interesting, you know, learning looking back. But I do think that we learned a lot from it in Facebook. But this was one big one. So,
that was one big one. Yeah, it was also surprised. I joined Facebook around 2017.
Yeah.
I came from Yahoo, and then we had part of Flickr. We did had some level of computer vision also there, and that was done all on GPU at that time. And so I was like, yeah, this is maybe it's different approach to things. It's like I could believe the hypothesis there. We have a lot of CPUs, so it makes total sense to go in this direction.
Correct. But we used GPUs for computer vision. We still use GPUs for computer vision for sure, because those are intractable to doing CPUs. And we use it for integrity, machine translation, things like that. But when it comes to sparse models, you could the models themselves weren't actually would fine to run on CPUs. But what we haven't seen is and this is a very good example of when you make the infrastructure available, you unblock new innovation, right? So had we made the GPU infrastructure available for ads and ranking recommendation models in general, would have seen a different kind of modeling architecture and modeling innovation comes earlier. And this is it's happening now, but these are it's tied together. So one unblocks the other and so on. You innovate in models, then you drive infrastructure innovation as well. So it's a cycle. So the co-design becomes really, really important.
Yes.
And I do think that this is the big lesson that we learned. Co-design becomes an integral part.
It's interesting the co-design aspect.
Mm-hmm.
Like me, you've been working for a while, and I started my career doing speech recognition.
Nice.
And it was on dedicated DSP boards. And dedicated hardware, and it was difficult to kind of manufacturers and get it in the hands of people. And over time, we standardize. We moved the algorithms to to back then was to Intel Pentium and all of that. And it feels like we're doing the opposite now. We're okay, now we're going with co-design, a lot of custom hardware, custom network, fully dedicated. It's we're doing a full 360.
I think it's a cycle. It's a cycle of innovation. And especially, I think co-design is very powerful when you have a domain that moves very fast and you want to AI moves very fast, and you need to cope the system and the infrastructure with it. So I think co-design is a good mechanism for that. Now, the problem is, how do you turn this co-design techniques into massive scale infrastructure improvement? So it's sort of a small cycle of co-design and quickly innovate with the researchers, learn quickly, and turn this into product innovation and infrastructure innovation. I think Facebook is really good at that. We're good at taking a problem and scaling it, right? So I think it's just finding the sweet spot and when to turn it into a massive investment versus
is that a test system type of thing?
Exactly.
So let's switch to today.
Yes.
You're now at NVIDIA, enjoying the rapid life and everything over there. If you have to share a little bit around hey, what are the challenge that you guys are facing today? From my point of view, admit that we're a user. We're not a producer. We're producing a little bit of our own chip, but we're a user. And we have very well-defined use cases. So what's happening at NVIDIA? What can you share with us?
It's really incredible, actually. So, the mental model about NVIDIA is it's a hardware company. We create this amazing GPUs and that's it, right? But joining NVIDIA, it's I opened my eyes into a completely different world. Especially over the past couple of years, I would say 2-3 years, NVIDIA went into becoming a big users of our own GPUs. So we used to we used to always have a small footprint of capacity that we used to develop reference architecture for.
Yes.
Here's what the DGX system would look like, right? And these capacity used to power researcher needs in NVIDIA, which was enough. But then LLMs happened, and then the world changed. So the innovation and research exploded, and the capacity needs exploded, which put NVIDIA into the position of a large scale infrastructure operator. Now we're operating large scale infrastructure, and we're seeing the challenge of like, what does it mean to actually like do this?
Yes, yes.
And more importantly, which I think is very interesting in NVIDIA, we have the full life cycle. So this is the first company I have worked in that have the full cycle, right? Operational excellence or operational expertise that can actually turn into hardware innovation.
Yeah.
Right. So there was a few talks today, for example, about like silent data corruption and how do we detect that at scale and what do we do with them and how do we improve the stack. We have a talk. My team is coming in AI and data at scale soon to talk about like a few things like that as well. But then you look at when this happens in NVIDIA, we actually like design the chips so we can go and actually fix it.
Yeah. Or you can put safeguard in there.
Or we can actually like know like, oh, the drivers are need like updates, or like, you know, these are bugs in the drivers or CUDA. So we have like having the full stack along with the operational experience at scale. I think it's these two combinations make it like really interesting in terms of closing the loop. Right, and improving the full product lifecycle.
Yes,
right?
yes.
So I think that's one of the challenges that my team is addressing in NVIDIA, not just offering these GPUs, like large-scale GPU clusters to researchers to make them productive, but unblocking product innovation all the way from the hardware, drivers, CUDA, everything around the ecosystem, and making this available to the rest of the industry. Would love to share more about this, like with everybody else, right? So that we can make the whole ecosystem better. Right? Everybody operating GPUs need to like learn about these techniques so that they can operate it better at scale.
I'm sure the PyTorch team will be like interested into this.
Everybody wants to know how to deal with NANDs.
Yeah, exactly. Or like the massive failure.
Right.
It is, you know, that I call it like the training algorithm today.
Right.
And, you know, I'm a bit removed from there, but I often hear stuff like, oh, I have like, you know, this task with 100,000 jobs or 100,000 tasks in it. And as soon as one fail, everything needs to restart. Like this is like mind numbing to me. Like,
that's the nature of the training problem, right? It's very, very difficult. It's one of the most challenging problems actually. So the nature of the problem with gang scheduling, that everything has to move. This is how learning happens. Everything moves at lockstep.
Yeah.
Right. And this is the biggest difference of fully sync versus async algorithms, for example, right? And this is why we have, you know, training reliability is one of the most interesting problems we've ever worked on, and continue to be one of the most interesting problems.
Yes,
for those reasons.
I think you know, Meta like being like, you know, let's call it like the provider of Llama today. Like we expect these things to be on a specific schedule, and when these failures are happening, this is like today it is as important as a production set. Like this is like, you know, this is super interesting. This is new.
When you think about it, like, you know, models train for like months.
Yes.
Right. And then you get like this metric, mean time between failure, like measured in K GPU hours, right? So if you're training a model on, let's say 10K GPU and your mean time between failure is 40K, then like you're failing every 4 hours.
Yeah.
Like no production system that we operated at scale, like traditional production system, you would imagine failing every 4 hours. Like that's just wouldn't qualify. Right?
That'd be a long day. Very long day.
Every 4 hours. How is like your life looking like?
Yes. If you add like one, like, you know, you've been at Facebook, Meta, you know, there's some basic foundational system.
Yeah.
Like we have this thing called Tao, which is like kind of like caching layer / social graph. We have these things like, you know, the storage system. Anything like this that did surprise you at NVIDIA, like, oh, that system is cool. Like we should have had that before.
Oh, that's a very good question. Okay. I think NVIDIA operates as a very nimble set of startups. So what actually like struck me in NVIDIA is how quickly teams can actually put something together to solve a problem. Not necessarily a specific system that we didn't have at Facebook, especially when it comes to production. I think systems in production here is like very mature, right? But I would say, and it's not surprising, like things around like GPU resiliency and understanding like, you know, failures around GPUs, right? This is very, very of course, this is the bread and butter for NVIDIA. I think what I'm discovering in like operating at large scale is, it's connecting the dots of operational excellence and operational understanding to the product improvement, and just showing, like, just linking these dots together and how fast you can see an improvement happening just by connecting the dots. It's like, we have this very common thing called XIDs. This is basically how the GPUs emits errors.
Yep.
So think about them as error codes, essentially, right? So you get XID 64, that's a very common one, ACC, right? You get XID 79, whatever. Like, you get like a bunch of them, right? And for a long time, like, these XIDs are there, and people learned how to like work around,
right. Swap it to another machine.
Exactly.
Yeah, and then send it to repair.
Exactly. And then it became like, a tribal knowledge based on operational experience and operational knowledge, right? And then when we're operating at scale in NVIDIA, and we're actually in the center of seeing these errors, addressing them, debugging them, and then we have actually an opportunity to improve fundamentally how they're addressed in hardware or drivers or CUDA or whatever. Right? So I think what impressed me in NVIDIA is ability to work quickly across the teams and across the stacks.
Okay.
Right? And like, given a problem, how fast we can actually solve it. So it's very famous in NVIDIA, the term speed of light.
Speed of light,
right?
Okay.
That's a very, very like integral part of our culture, like how fast you can deliver something.
And this is how fast you can like kind of like communicate between teams and kind of like...
Speed of light is a concept you can apply in anything. Like speed of light on how fast we can solve a problem. Like how, and this is basically like we're trying to test the limit of physics. Is that nothing can beat the speed of light. This is the physics rate limit. So how do we remove bottlenecks in order to achieve the speed of light, right? That's an integral part. And I've seen the speed of light in action when it comes to like, okay, here's a problem. How do I solve it, right? So it's really impressive.
Do you feel that there is like some special like cultural element that enables this?
Few cultural elements. So I think in NVIDIA we say the mission is the boss. Right, everybody is like centered around the mission. Team boundaries are like org chart essentially like is meaningless. Not completely meaningless.
Something you need, but it's like something that you know
exactly.
You do not.
It doesn't come in the way to actually solve a problem.
Okay.
If you need, and I see this all the time. Like it's very rare to you can bring in anybody in the company if you have a problem that with well-defined mission. You can rally anybody across the company behind it. It doesn't matter where they are. Doesn't matter what team they are in. Doesn't matter where they report to. And nobody asks, like, hey, I need your help. Here's the mission. Everybody aligned behind the mission. Then everybody jumps in. Everybody tries to solve the problem, regardless where they are. And this is how we can get, because a lot of these problems are cross-functional by nature, right? In order to solve some of this reliability problems for training, you might go all the way to the hardware design. And, this is like, a 30,000 person company and many, many different teams. So how do you actually like thread the needle across so many different teams and so many different organizations? So the mission actually makes it like the mission is the boss is what we say, right? So that's one unique cultural element I've seen in NVIDIA. Like,
I've seen this also at Meta and Facebook. Like we have, let's say, like, a problem is not like, anyone else. Like, nothing is someone else's problem.
Exactly.
It works great.
Yeah.
But I always find it difficult to like teach, let's call it the younger generation about like, go and fight it, go and hunt it now.
Yeah.
Like we will support you. Like there's no boundaries. And I was wondering, like, do you guys have like, how do you like kind of promote that culture with younger engineers?
They really like, the best way to promote culture is to like just live it. Like, just act it yourself. So, and then your team mimics it immediately, right? So that's like, that's the easiest way to show culture. Show it by action, day in, day out, small actions with how you make decisions, with how you actually solve problems, right? So this comes all the way from Jensen, actually. So I was like, hey, the mission is the boss, how he operates, how everybody under it operates, and so on and so on. So it trickles down, right? Speed of light is another, like, how do we think about speed of light? Although, with new people coming in, they're always like, hey, teaching what does it actually means, right? And why do we think about speed of light? We're actually thinking about it in order to identify bottlenecks and remove bottlenecks, not necessarily to work at the speed of light.
Yeah.
So I think this is how we do it. Like, people see their managers act this way, then they start to mimic this behavior.
Great. So speed of light, mission is the boss.
Mission is the boss. Yes.
Is there anything else that did surprise you in terms of like culture, how to operate, or little behaviors?
So we have this culture as well about like, hey, if there is a problem that is important, no matter where you are in the company and your help is needed, you'll come and help.
That's great.
So I think it's actually very call for help is immediately answered, right? People are very helpful and they go out of their way in order to help. Like, if they're asked for it. I think this, and it's a very forgiving culture as well. I forget to say this. And I think this is actually very, very powerful. Because this combination, when you're trying to like push the boundaries using concept like speed of light, right? And rally behind the mission. When you combine it with a forgiving culture, you actually infuse a culture of learning, right?
Yeah.
So it's not very stressful. It's not, you don't feel like, it's very tense in terms of...
Yes. People can operate more in kind of like, I would call it like a flow state type of thing. Like they don't have to worry. They have like the structure. Exactly. The company has their back.
Exactly. Yeah. So I think this is like, again, like I attribute this to a lot of like, Jensen like philosophy. Like he really bets on people, right? He really like tried to get the best out of them by empowering them. So it just brings the best out of you. You want to do that because you feel like you're aligned with the mission and you're really excited about the challenge and you know that it's a forgiving culture. So you know that you're going to learn. So there is a lot of like betting on people to learn new things all the time. And this is how NVIDIA actually over the years were able to pivot quickly, especially with the AI pivot like recently, right?
Yes, this is great.
Yeah.
Switching gear a little bit. So there's a lot of buzz around AI. What would be your favorite application or product that you use yourself?
Okay, that's a very good question. Yeah. So I found actually like the Copilot that is integrated with Teams, and it might be like, are you actually using Teams? Yes, we're using Teams.
Hey,
no judgment. But the Copilot integration with it, I found it very incredible. Like for me, busy day, I want to catch up. I want to understand like how my teams are making decisions, empower them, help them. And there's just a lot of flow of information. And it has like really nice features, summarize the day, right? It just shows you exactly what was the action item of a given meeting. So like I can save like hours of meetings by just, looking into what is the summary, what is the action items, who's assigned what. It does actually a really incredible job in doing this and tracking your action items and stuff like that. I found this very, this productivity hack. I all share it with my team and I found it very, very useful. So it's something practical I use every day. And it just, it made my life much easier.
Yeah. I think we have something like very similar internally. It's called MetaMate.
Nice.
And it does the scanning of like all our, our internal tool is Workplace.
Right.
Like it does like all decent scanning of it. And now it's including a bunch of like Google Docs. We use Google
very
Docs.
Good. Yeah.
Very good. And then the summary feature, and it's actually like amazing because you can kind of recap and exactly, okay, I need to focus on this. Exactly. I missed that.
Exactly. And like I found the same feature available in email as well. Like just long email threads. I know we're very heavy on emails internally. So with long email threads, you can just sum it up for you. And it's like, okay, it distills it down. I was like, awesome. This is exactly what I want to read.
And for me, like I think one of the tools that I've started to use a lot more is Notebook LM from Google. The fact that it can absorb multiple modality, like I'm using it to plan like travel for the summer.
That's awesome.
Like you look at like an hotel or like, a destination, and I found YouTube videos, I put them at source and they start asking questions and and okay, give me the least expensive 4-star hotel
it's
type
like,
of thing.
You can on the personal life. I used ChatGPT recently to plan a trip with my daughter during her spring break, and we went into an RV trip. And I was like, okay, it's the first time I ever go on an RV trip. I have no idea what I'm doing. She doesn't know that, by the way, so she's gonna learn it in this podcast. So I went to ChatGPT. I was like, okay, I want a 5-6 days trip. Plan it for me. What should I do? And it turns out very very good and thought through it. And here's you're gonna park your RV. What are you gonna do?
That's out of curiosity, what was the destination?
Oh, so we went into a tour in California here. So we started with Santa Cruz. So she loved the boardwalk and rides. So she had a lot of fun there. And then we head to Monterey. And it was really great to see the zoo and stuff. And then to the mountains, to what is it called? Mountains and
like the Sierra, Tao, or more like Yosemite.
Yosemite Park.
So you did that loop.
We did
down.
the Yosemite Park loop, and then we came back to San Francisco. So it was really cool.
That's awesome.
Really cool.
That's awesome.
It was the first time in RV, so
yeah.
It's a pretty cool experience, actually.
I've been debating also with my kids around doing it more in the Cascade, like in the Seattle area, and kind of do like Leavenworth and
nice.
But you got a point, like where do you park the RV at night? Like, where do you find the stop? Like
ChatGPT to the rescue. It did everything.
So if I was to go back a little bit to let's talk about management philosophy.
Yeah.
Because you've been, dealing with teams for a while. It's something that's usually you have some easy times, and then sometimes there's some hard time, especially when there's pressure of hard deliverables and stuff like this. What have you learned over the years that that helps you make a large team or a group of people function well together?
Yeah. I'm not sure since I joined AI, I had an easy time, but
when things are hot and in the news, things are easier.
It has been a roller coaster with AI. I think I'm grateful for the experience that I had. I've seen the Meta and the Cruise and the NVIDIA. A few things actually. So I think I found when you're building a team, infusing in them this culture of problem owners. Is very important, especially in the AI field, because you actually you have to solve problems, as I mentioned earlier, co-design, co-develop with everybody, with researchers, with hardware, with software, with systems. So you work really across the stack. So it's very important to have this mindset of, an end-to-end problem owner, right? So I found this very, very important. And one way to infuse that problem, I found also very effective, particularly in my experience in Cruise, is embedding engineers into research teams.
Yeah.
Really having them join these teams and work side by side with researchers, owning the same goals, right? My analogy for that is, if you're really trying to improve developer productivity for a given type of developers, let's say hack or PHP developers, you yourself better be.
You need to understand, you need to understand the flow. You need to
right?
Have written more than the hello world.
Exactly, and I think this is we in Meta we used to have, and I think we still have an incredible infrastructure when it comes to developer productivity for PHP, for hack, for dub. It's so good, and it got perfected over the years because a lot of people with this mindset, they're really good PHP developers, actually invested in building infrastructure for developers. So it becomes really good cycle. Now, if you really want to improve the experience of AI engineers, you need to live in their shoes. You need to train the models the way they are. You need to see the life cycle of all the way from idea inception to idea production, right? So I found that very, very powerful. And every time I applied it, it led to an incredible results in terms of productivity of researchers, a lot of insights, opportunities for people to grow. So really exciting to to operate in this model. So end-to-end problem owners, embedding.
It's interesting. Your embedding is a bit different than mine. And I have not done embedding of researcher or engineers recently. But in the years when I was in core system, it was kind of the opposite of probably what you're saying. Like we would embed kind of like a researcher slash specialist of something into the engineering team to help tackle like that specific issue.
Kind of like bring an expert to the team as opposed to,
Yes.
I think this like definitely have its own value as well, but I found the biggest value comes the other way
from the other way around.
And then this mindset, like we always as infrastructure, like my background is infrastructure to begin with, like as infrastructure engineers and leaders, we always think about infrastructure health and scale and reliability and efficiency and cost. Those are the things, those are the terms, the currency we think in, right? But I found it's very, very important to think in developer velocity, really, really understand your customers. Your customers at the end of the day are enabling, when it comes to AI infrastructure, it's about enabling AI innovation. It's enabling AI research. It's really important to understand this customer angle. And the more that you center your goals around it, right, the more the other goals will come naturally. Like, why do we drive GPU efficiency? Well, of course, to save money, but actually it's to like
to do
create more like GPU bandwidth for the researchers to use, right? So it's the same goal, but if you shift your perspective, it will result into a different way of being obsessed about the customers versus not. So I found this very, very important, especially when you come to work with researchers and support AI.
Any regrets on decision that you made or management style that you adopted with teams over time?
Yeah, like, there's always like, several things that I reflect on. And, I learned over the years that putting people in the center always pay off, right? So no matter what, like invest in your people and support them, create this forgiving culture. It's very, very important. So I worked in many different cultures that focused on different perspective of performance management and so like, goals and all OKRs and goals and deliverables, and they all like have their own pros and cons. But I'm really enjoying, NVIDIA's culture for that reason. It's, here's a mission. I had a lot of smart people. We trust them.
And then
everybody's technical.
Yeah.
All the managers technical. Everybody's technical. And everybody's centered around making the mission happen. And then that's it. And it's a forgiving culture. So people are excited to learn. People are excited to grow. And you just see like incredible results. So I found that very, very, very valuable lesson throughout the years.
One of the things for me was younger in my career, I had a tendencies of putting, I would call it the same archetype together.
Right.
And I've learned over time to more like switch it. Like it's more like, do you remember the movie Moneyball?
Yes.
Like very different people for very different skills. And as long as I get the mission or some level of cohesion, that's going to create some level of magic.
Yeah.
And it takes time because you look at your crew and you're like, wow, those are very different people. Like,
that's actually like, it's something that I always found diverse team, right? To be very, very powerful, right? And I was like actually very proud to see like teams, always diverse teams. Diverse in terms of backgrounds, in terms of skills, in terms of approach to the problem. It really creates a lot of, innovation, I would say.
All right. My last question, okay? If you and I have this conversation 5 years from now, where do you think the world is in terms of AI utilization, either for assisting in our work, but also like, everywhere in society, but like 5 years from now?
Yeah. Well, first of all, I'll be driving in my self-driving car here. So I wouldn't be worried about parking.
Yeah, okay. Yeah. We'll drop you and you have to walk the rest.
That was a little bit of a nightmare.
Yeah. I came in Uber. So
right. I do think agentic AI is definitely on the cusp here of doing great things for the world, right? Whether it's, I think self-driving is just one way, right? Yeah. I do think robotics actually, this is a generalization of it, and we'll start to see more and more of these applications, right? Coming into the real world. And it comes with a very interesting like debate about like safety and, you know, a lot of interesting elements, interesting aspects of how to make this AI safe, or there is always like the fear of AI taking the world and stuff like that. But I look at it as, I do think it's going to complement our life, make it better, right? I didn't have to think about, you know, where to park my RV.
Yeah.
Next time in 5 years, I don't have to even worry about driving the RV. I'll just enjoy my time.
You'll just go in the RV, say, I want to go there, and there. And we'll sleep at 7 at night because we're tired.
Exactly. I do think, you know, AI is... 5 years ago, we said like, oh my goodness, we're in the beginning of AI. And 5 years later, we're saying the same thing. I do think it's just incredible how we fast innovate, and it doesn't seem that we're hitting a wall yet. It doesn't seem that we're just scratching the surface. So it's really exciting times.
So, hey, it was great that you brought up the agent topic. This is actually one of the main topics for our next event, AI and Data at Scale. That will be happening on June 25th in the Bay Area. Hoping people can join. And thank you for your time. This was great, and see you next time.
Thank you so much for having me.